General steps. Set the multimeter to diode mode. Place the black probe on the common terminal and the red probe on the positive. Test the negative pins and phases U, V, and W. There should be no reading. Reverse the probe's polarity. Typical voltage drop should appear, around 0.813 volts between negative and positive. Keep the black probe fixed and test with the red probe on U, V, and W. All values obtained should be very similar. In some modules, values close to 0.412 volts are obtained.
If any pin shows 0 volts or values that are too low, it indicates an internal short circuit or leakage. The module is damaged. Now reverse the probes. Leave the red probe on the IPM negative pin and place the black probe on U, V, and W. The readings should be very similar in all three measurements. In some electronic modules, you may expect values between 0.412 and 0.485 volts. If all readings are consistent, the IPM is in good condition without needing to remove it from the board. Fourth method. Test with the PCB energized. This is the most conclusive method, but also the riskiest, since it involves working with voltages up to 300 to 320 VDC. It must be carried out with extreme caution and only by personnel experienced in power electronics. Typical tests. Measure between positive and negative. It should be between 300 and 320 VDC. On U, V, and W, values between 10 and 15 VDC should be recorded, stabilizing around 11.7 volts depending on the manufacturer. Characteristic failure case. An IPM may pass visual and multimeter tests, but when the PCB is powered, the fault becomes evident. For example, if on phase V, instead of approximately 12 volts, 304 volts appears, it means the IGBT of that phase is short-circuited. In such a case, the only solution is to replace the entire module, since the damage is irreversible. With these complementary methods, it is possible to perform a complete diagnosis of an IPM from preliminary inspection to final verification under real working conditions. Knowing and applying these tests is essential to ensure effective repairs and avoid recurring failures in modern inverter systems.